Guys, those of you that have been with us for some time, you should help us to market, ne? Just share the things out there, the links and so on. Say, just see what I'm doing, right? How hard I'm working to pass.
So
You know,
it's $100 per egg.
away. Mauritius, my entrepreneur, huh? Okay, I get you, man. Okay, let me do this. Let me give you $50 for every client that you bring in. Every successful deal, for every successful deal this 2020. Let me do
Just
that.
50.
I mean, under 2022. Yeah, I mean, if
For
you
a person
bring
that comes through.
yeah, and registers with us. It can be grade 10, 11, or 12. Anyone. If you have maybe no. Let me see. If you have 10 of them, I'll look into your monthly amount that you're paying. Maybe I give you a 50% discount. Maybe if you have many, you can even attend for free.
Oh.
now we're talking, huh?
Isaac,
So for your AS level, you can attend freely, ne? Just go and market out there, guys. This is the time where we need influencers, ne? Who are the influencers on the group? Put up your hand, guys. Influencer.
Uri.
Luther, my man. It's Uri.
Mauritius.
Uri.
Okay. Blowing your own horns, huh? Okay. So, guys, I am ready to go. You still see my screen, right?
Yes, sir, we can see the screen.
Okay, so I've got some participants that are raising their hands. Belinda, Maria. Okay, Belinda, you've got a question. Maria, you've got a question.
Sir, it was for the previous questions I was asking when we were discussing something else.
Okay, what was that about? How may I help?
Sir,
Mm-hmm.
until when will the outsiders be allowed to join the meetings?
Just for today. Just for today. I think we've done enough. We did it for the past 2-3 days and so on. So after that, we'll stop now. From later today, we'll just privatize. Okay. If they want to join, they can always come and talk to me. Right. So Yebo.
Does still have that Izuka card where the price list is?
Yeah, no. I'm gonna create an advert, yeah. For 2020, we're just focusing on the exam. So all that advert, everything I'll share with you, whether it's a short video, whether it's a poster, whether it's a link to something, or maybe you can also think of creative ways to share it. Né? What will entice youngs? Okay,
so what happened
platforms.
to the website?
If you do what?
What happened to the website?
The website is available. You can always go and check it out. www.pan.edu.na. It's there. I just need to revamp it to put some of your pictures and so on. I've got an idea. I want some few people that we want to do something with, some content creation. But let's focus on the physics for now. Né? Yo, Lesuku, radioactivity is a problem for you, huh? Yay. Okay.
What is that?
Gift is setting out that thing. Belinda say outsiders. We're giving people terms here, outsiders. Okay, but anyhow, yeah, I see your topics, guys. I see your topics. Okay, so I will go through the messages afterwards and then look through it. Okay, right. So, yep. So let's look at this question. This question is on motion. So Maria, you can put it down there. Motion. It's enough to just say motion. You don't need to be specific with velocity, acceleration, and so on. So here we have a speed time graph. So speed is represented on the y-axis and time is represented on the x-axis, telling us x-axis normally takes the independent variable, whereas the y-axis is taking the dependent variable. So what it means is that the time will keep moving, whether you are driving fast or slow. But the amount of time you take to reach will be dependent on the speed that you're driving. So that's what we mean with the dependence and independence of this. So you've got Thuli and Polar that are running a race. Okay, so now you can see the graph of Thuli and the graph of Polar. So here, the first one could maybe say, sorry, let me just see how this works. Okay, does it want to take my highlighter like that? Let's see if it works. Okay, but anyhow, it doesn't want to work. So Thuli's graph is over here and Polar's graph is over here as the names are indicating. Okay, so with that said, we can already see, since we know the topic, the steeper the graph, the faster you run, because you're going to cover a certain distance in a less amount of time. And the more gradual the graph is, the slower you run. Because if the graph is flat like this, that means you're not moving any distance, although the time is still moving, even though you are stationary. Does it make sense, guys? Okay,
Yes, sir.
so having that in mind, we can already see that Paula has been running faster, but we don't know whether she covered the most distance. If we want to calculate the distance, we'll now look at the area under the graph. So we'll have to close the graph, because you can't calculate the area for an open figure. So you form that triangle over there. And then we do the same thing with Tuli. We close it there. Then we look at the two triangles, the first one and the second one. The area of a triangle is half base times your height. We check which one will have the greatest area. The one with the greatest area means that you've covered the largest distance, or you've traveled furthest over there. Okay, that is just some summaries and some pointers that I want to put before we look at the questions, okay? Because those are the things that they ask mostly. So let's look at the question now, okay? Now the question says that determine the speed for polar. Now speed, we said, is the gradient of the graph. So you just need to find the gradient of the graph to determine the speed. What's the gradient? The y change over the x change. How is the y change changing over the x change? Y change is that on the y-axis, that is your speed. Are we together? And then the x change will be the time. Oh, sorry, I'm not looking at the screen. Is there a hand up?
So I want to ask, isn't the gradient in this case going to be the acceleration, because we are working with the speed time graph?
Oh, yes. I'm working as if I'm going for distance time graph. Okay, yes, you are correct. So the concept I'm trying to explain is something else for the distance time graph. We'll highlight on that as well. Nah? So what is being represented, thank you for that correction. What is being represented here is the speed. In what? In 20 seconds. Now, so you're going to go here, and then you're going to draw a straight line from 20 all the way up to where it touches the graph, isn't it? Are you following, guys?
Yes, sir.
Did they say in the first 20 seconds for polar? And then after that, what you're going to do now? After you're done with that part, what are you going to do?
You draw a line connecting to the speed.
Yes, so you now have to draw a line that is parallel to the x-axis, and then you can read it up there. So I don't have a ruler with me, guys. So if you have done this, let's say this properly, it could have been maybe a different, I don't know what we have there as the answer, but maybe
6.4, 6.5.
Exactly. So anything between 6.4 plus minus 1, eh? You minus 1.
Yes.
So it could be anything, not actually 1, but 0.1. 0.1. So it could be 6.3 or 6.4 or 6.5. Are we following, guys? So plus minus that will give you the speed in that. All right. What about at 25 seconds? What was her speed at 25 seconds? Just by viewing that?
It was at 8.
8. So go from 25 between 30 and 20, go all the way up, and then you read the 8 over there. Now I want to know what was her, what else can we ask? At what time? At what time did she reach the speed of 4 meters per second? So now you do the opposite. Go to 4 meters per second. Draw to the graph. When it touches the graph, you come down and you read.
It looks like 13, 12.
More or less, maybe. If you look at the distance here, is 15 over here. Yeah, could be anything there, 12, 13. Are we following? So it could go both ways. Are you following, guys? All right. So any questions? Are we fine? Right. So let's go up. Determine the speed at polar. We said it should be roughly 6.4. They say the figure 2.1 is an equivalent to your velocity time graph. So they are trying to tell you that that figure, instead of having speed over here, we're now going to have velocity. That's what they mean with equivalence there. And then we've got the time on this axis. So they say calculate the acceleration of polar. So the acceleration of polar now, it's almost the same thing that you asked, that Rosta was correcting us there. So you're going to do what I showed you here. So if this is polar, the acceleration will be the gradient of that graph, because acceleration is the change in velocity over the change in time. Velocity is on the y-axis, whereas time is on the x-axis. So it's the same thing as saying change in y over the change in x. So this is the velocity, the change in your velocity over the change in your time. Together. Sorry, my teeth looks funny. And then you get that. So you're gonna go and see the change. So if we take all this out of here, and we want to,
over.
so you can take any 2 points. You can take any 2 points on the graph. But I would take this point over here and the first point. The reason for that is because the values that I would get here would be a solid 8. Are we together? Here I would have a solid 25. Here I would have a 0. So at this point, if we make this our first point, are we together? We want to see how did the x and the y-axis change. So let's focus on the y change. So the change in y, so how does that work? So the y was 0 over here. It moved all the way up to 8. Are we together? So the change is 8. You could put it like that. And the change here, because it's moving from 0 up to 25, the change here would be 25. So that's the change in your x. If we do it the way we do it in mathematics, we could say my x-axis is 25, my y-axis is 8. My x-axis is 0 and 0. So you could say maybe this is my x1, y1, and this is my x2, y2. So the change in your y and the change in your x could have been seen as what? Just to say y2 minus your y1 and x2 minus your x2. You get the same thing, because your y2 now is 8 minus 0, which is just going to be 8. Sorry, guys. Okay. So 8 minus 0 will just be 8, which we have.
So the y2 is 0.
Pardon? Yeah. No, the y, I made the y1. Okay. Yeah, I get what you say. So it will be 0 minus 8, which is just going to be negative 8. Okay. And then at the bottom would be 0 minus 25. So it will be negative 25. Negative cancels. It's still the 8 over 25. If you simplify 8 over 25, what does it give you? What do you get? Maybe 0.33 something. I don't know.
0.32.
32. Okay. So the answer here will then now be 0.32. Are you following? So look at the unit here. I always try to explain this unit over here. The change in velocity over change in time. Velocity is in meters per second. Time is in seconds. So this thing means take the meters per second and divide it by seconds. That's what it means. Take that and divide it by that. So if that is done, this over 1, since you're having a fraction divided by a fraction, if you change this to a multiplication, then the term after that must reciprocal. So you will have m over s multiplied by 1 over s. When you're multiplying fractions, you multiply numerator with numerator, denominator with denominator. So s times s, bases are the same. You add the integers or the powers, then you get your meters per second squared, which can be written as meters per second squared. Does it make sense? Okay. All right. Questions? If there are no questions, we can move on. Now the last question, or not the last, I don't know, maybe it's so continuous. Compare Polar's acceleration with Tully's acceleration. Now guys, in order for you to compare, if you don't know the concept of the steepness of the gradient, you go and calculate Tully's acceleration. And then you see if Polar had 0.23 and Tully is roughly whatsoever, then you would say, if this is more than Tully's acceleration, you'd say that Polar's acceleration is more than Tully's acceleration, or Polar is moving much faster than they. So let's quickly look at Tully's acceleration. The change in y will be 4. The change in x will be 40. So 4 over 40 will give you 1 over 10, which is 0.1, isn't it? So Tully was moving at 0.1 meters per second squared. If you look at the acceleration, and then this here was moving at 0.3 meters per square. So Polar's acceleration is much greater than that, or Polar is moving at 3 times as faster as that, if you want to be very specific. But just to say that Polar is moving faster or her acceleration is greater than Tully's acceleration will give you that 1 mark. Does it make sense? Okay. All right, guys. Are we all together? Good stuff. So we can move over to the
Yes,
next
sir.
question. Now, Thule's distance, calculate the distance covered by Thule. What is the distance covered? Distance covered will now be your area under the graph. Are we following, guys? The area under the graph, okay? So you have to calculate. So if Thule was moving up to there, I cannot calculate. This is where we get stuck, guys. I need to close this in order to find the area. Have you ever calculated the area of some shape that's open? Maybe you wanted this to be a rectangle, but it's not closed. And they say calculate the area. No, you have to close there before you can get the area. So if the graph is just going like this, I have to close and then I get the area. Are you following, guys? Okay.
Yes, sir.
So now the base, because this will be area is equal to half times your base times your height. The base is down here. This is your height. So Thule had a height of, I think, 4, and the base was 40, isn't it? If you go back to this.
Yes, sir.
Okay,
Yes, sir.
so Thule was 40 here. You can see the base is 40 and the height is 4. So you'll say half times 4 times 40. This will be what? 4 times 40, or you can even say half times 4 is 2. 2 times 40 will give you 80.
Once.
What is it? Is it? No. It should be 80. Okay.
So 4 times 40 is not 180. 160.
Yeah, no, but 160, half of 160 would be 80.
80.
I just already get the half of 4, which was 2. So if you do that correctly, the distance under the graph, or the distance, not the distance, but the distance covered by Thule would be that. So you would say the area will be equal to half base times height, half times your base of 40 multiplied to height of 4 will give you 80 meters. The meters come because the 40 here is in what? The 40 is in seconds. You multiply with 4 meters per second. So if you write it nicely, this is what it looks like. 4 meters a second, seconds cancels. That's why you only have the meters over there. That should be very clear, isn't it? Now explain the difference between speed and velocity. We have shown with the other one as well.
So
Speed, yes.
Speed is a scalar quantity and velocity is a vector quantity.
Yes. That is also, there is one way of saying it, that we can say speed as magnitude and size. Only magnitude or size, with only a scalar quantity, where velocity has got both the magnitude or the size and the direction, which makes it a vector quantity. One other way also, if we have to define it in terms of the formulas, remember when Rosta was asking that, I said that it's always good to look at the formulas. Now let's put the formula for speed. So speed will be the amount of distance that was covered over the given amount of time. What about for velocity?
Velocity is
Displacement over time.
Displacement over time. Are we following? All right. So you can now say your velocity. All right. Velocity will now be the displacement over the time. So it could be the rate of change of displacement here, or the rate of change of distance. The reason why we say rate is because of the time. So one could also put something alternatively and say speed is the rate of change. How fast does it change? What is changing? The rate of change of your distance. You know, when you're driving somewhere, yes, you're getting closer and closer to a place, isn't it? That's the rate at which it is changing. What happens to your distance? The distance becomes less and less and less over some time. So if you use the same thing, what will you now say for velocity? We'll say velocity is the rate of change. Of what? Displacement.
Direction.
Not direction,
No.
displacement. Okay, displacement already tells you that it has got direction. Okay, it's not the direction that is changing. You could just stand there and change to the north, the east, and the south, and the west, but you're not moving anywhere. Your speed is 0 meters per second, or your velocity will be 0 meters per second. It's not the direction that's changing, it's the speed. Are you following, guys? Okay. On this note, another definition for acceleration would be the change in your speed or change in your velocity. Are we following? More on the velocity. So as soon as we see this bold number in your square brackets, that means it's the end of the question. Then we move over to the next question. Some questions I'll skip, guys, that I feel like we've done there. So Maria, we've done motion. Okay.
Yes, sir.
We've done moment and so on. This question we already looked at, so that we can tick. Right, so let's look at this one. Now this question deals with energy, Maria. This is where you've got kinetic energy, your potential energy, and so on. So what we have here is a palm fruit falling from a palm tree, okay, at point S before it comes to rest. So this is at point S. At point S is what? At rest. Né? So what does it mean? Your speed will be 0 meters per second. Now, the palm fruit is falling down from there. Are you following, guys? So those are some of the ideas or the things that we need to take into consideration. Okay, so if that happens, let's go to the questions. Sorry, we have this over here. And by the way, when this thing is falling, because it's a free fall, due to gravity, this thing is moving at what? 10 meters per second square. Yeah, the reason why we say square is because its acceleration, it is in a specific direction. Together, that's why we use the velocity, because it's going down due to gravity. Okay, so we've got that part over there. Sometimes people are getting confused to say, is acceleration in meters per second square, or is it, I mean, the gravity in meters per second square, or so on. Are you following? Okay, so guys, if this is done correctly, let us look at what we are having over here. Okay, so now they are asking us to do what? The mass of the palm is given as this. They want the weight. So again, weight is equal to mass multiplied by gravity. So that if you make that the subject of the formula, you first have to change that mass of yours into kilograms. Né? What did they tell us? It's 125 grams. So if you divide that by 1,000, it should be 0.125 kilograms. You multiply that with a gravity of 10 newtons for every kg. Kg cancels, multiply by 10 will then be 1.2, isn't it? 1.25 newtons. Okay, we've done this question before. I'm going to move through it. You can always go and watch the YouTube link if you are getting a little bit, yeah. So anyhow, so if we move further, the palm fruit moves at a constant speed just before it hits point S, where it is now at rest. State the relationship between the upward movement and the downward movement. What it means is that as this thing is falling down, this is the downward movement. The upward movement is the air resistance, né? Because it's falling in air. And around air resistance, we've got air particles there. Né? So they are also moving against this. So that's what they mean. Are we together? So if this now is moving at a constant speed, that means this speed that is coming down is not being opposed by any other force. Are we together? So we can almost say it's inertia just before it hits the ground. Are we together? So the forces are equal, or the forces are the same, or the forces are in equilibrium, or the forces are balanced. So if you have now to state the relationship between the upward forcement, I mean the force, and the downward force. This upward force and the downward force, what's the relationship? You can say that these forces are equal, or you could say that they are the same, or they could say that they are in equilibrium. I hope I'm spelling that correctly. Or they could say that the forces are balanced. Just 4 or 5 different ways of saying any of the same meaning. Doesn't matter, no? All right. So we are done with that question. So we go over at point S. We know that the palm is not moving. The fruit has a velocity of this. Are we together? Vertically downwards. So they're going downwards vertically. So the velocity as it's going downwards is 11 meters per second. Are we together? And it's not second squared because this is just velocity. Okay. When it hits the ground, it comes to rest in just 0.2 seconds. Immediately, almost like instantaneously, then it stops. Okay, now they're saying calculate the average deceleration of the fruit. Now, guys, whenever you have to calculate the average acceleration or deceleration, you have to take the total velocity, divide by the time taken. Are you following? So the fact that they say deceleration is because it's moving down in the negative direction. Deceleration is just acceleration that is in the negative direction. So the acceleration we know is the change in velocity over the change in time. So basically, they're asking us calculate the negative acceleration. That's what the question says for the deceleration. Are we together? So if you do that, then you would now say the velocity would now be negative if you want to specify the direction, or you could just say that final answer would be downwards. So it will be 11 meters per second divided by 0.2 seconds, because that's the time it took to stop. Are we together? So if you do that correctly, this should give you 55 meters per second squared. So you could say 55 meters per second squared, but the fact that they say deceleration, you don't need to put the negative. If the word is not there, then you put the negative. If the sign is there, it already accounts for the word. Does it make sense, guys? So you could just put there either like this, which is not applicable in this question because they already tell you that it's deceleration, meaning it will be a negative acceleration. So the answer is just to put 55. That's it. Nothing else. Are we following?
So they'll mark you wrong if you put the negative.
Yes, they can mark you wrong because we don't really put the sign there. In some cases, technically, it's not wrong to put the sign. Are we together? You can just come and say 55 meters per second square, the deceleration. You can write it out. But if this was not here and you put the negative, that's correct, Rosta. Are we together? But the word deceleration is already accounting for the negative. So it's like you're saying negative, negative, which they can say, what if they plus each other and then they show, multiply each other and they show positive? You understand? So you want to avoid that confusion. So if the word is not there, you can put it there, or you could even write it down yourself as the word if it was not there. Okay. So the next question is saying that calculate the kinetic energy of the palm fruit just before it hits the ground at point S. Now, I want to tell you an interesting thing here. We know the law of energy conservation, isn't it?
Yes.
Okay. It says that the energy could never be created or destroyed, only change from one form to the other. Are we together? So which means that kinetic energy, right, when the palm is moving, is exactly the same as before it started moving, which will be your potential energy. If it asks you in that sense, but this question is not like that. This question just wants you to calculate the kinetic energy. Now, kinetic energy can be denoted like this, or we can say kinetic energy. So we can say kinetic energy or kinetic energy. Both of them still apply, right? What's the formula for kinetic energy?
Half times
mass times velocity squared. Are we together? We've got the mass of the palm as 1.25 kilograms, and we've got the velocity as what? We calculated in the previous question, isn't it? 55 meters per second squared. You multiply that with half.
There wasn't the acceleration.
What is that?
Calculated.
Didn't we
calculate the...
Oh, yeah. What is the velocity? The velocity was given there as 11, isn't it? And that 11 you need to square. Does it make sense? Let me quickly repeat that. I am getting ahead of myself. Guys, if you disconnect for some reason, are you able to connect without me accepting you? If you just put the meeting password and what it wants me to accept. Maybe I think I must change that setting, that once you're already in, then you just have to, I'll check out that setting so that I don't keep you hanging out there in the waiting room. Right, so we said that the kinetic energy will be equal to half mass V squared. Yeah? So your half multiplied by your mass of 0.125 kilogram multiplied now by your, what is this? 11. I need to put the units. Let's just do this. Okay, let's just say multiply by my 11 meters per second, and then that has to be squared. So that square will go for the 11 and for this and for that. So in other words, we are having half multiplied by 0.125 kg multiplied by the square of 11 should be 121, right? Meter squared, second squared. That's what we're dealing with, because the meter, second, everything has to be squared based on the rule in mathematics where you have this, isn't it? Under indices, everything in there are squared. Even if you had 3ab, and that we would say 3 squared, a squared, b squared. So 9a squared, b squared. That's the concept here. All right. So if you press this in your calculator, you ought to get 7.5625. All right. What are the units? Since it's energy, it will be in joules. But from the calculation, this tells us it will be kilogram multiplied by meter squared times it by second squared. Does it make sense?
Yes,
Okay.
sir.
So even
Yes,
if
sir.
you had put it like this, it's fine, because one of that is equal to 1 joule if you have to convert.
So,
Right.
So we
Yeah,
don't
boy.
have to round off our answer.
Yeah, it depends on the front page. I don't know whether they do that with a mass, but you know, 3 to 5 or 4 decimal places there is almost an exact answer altogether. So even if
Okay.
if they're not specified, just put the 3 to 4 decimal places so that you are safe. Okay, so that question is fine, isn't it? All right, I want to show you a similar question to that, just so that you see another way that this could be asked here. There was a renovation happening here, and the builder went up, and then one brick fell down. This is the mass of the brick, and this is the distance that it took the brick to fall down. Okay, so by accident, he dropped that brick at a height of 3 meters. Now state the form of energy that you have for this case. What it means is that state the form of energy the initial gravitational energy is converted to as the block is falling. Now, if it's sitting here, it has the potential to fall down altogether due to gravity. Now he touched it and it starts to fall. So they want to know how that potential energy, when it was stationary, is then changed to other forms of energy. Maria put down energy there, né? Conversion of energy. We looked at this as well. Okay. So now you need to be specific to say what is happening in that. Let's see if the entire question is here. Does it go over to the other page? Okay, it goes over. All right. So what is going to happen here is for you to tell me what energy conversions you are having. Does it make sense, guys?
Yes, sir.
Okay, so we're gonna look at the energy conversions that one would now have going through this situation. I don't know whether I just put this question together with it, whether it relates to the same, but yeah. Sorry, guys. All right, so let us then say, what will that energy change be?
To kinetic energy.
Kinetic energy.
And
What
then after kinetic energy, what happens, guys? It's changing the different forms, isn't it? So the marks that you'll be getting is the kinetic, because they are saying, let's just try to erase some over here. We need to understand the question, okay? They are saying state the form of energy, the initial gravitational energy is converted to as the ball. So we'll just say this will now be kinetic energy. Does it make sense? Okay, 1 mark for that. Now, to what form of energy is the, in what form is this energy converted when the block hits the ground? What form of energy is that? Some might say sound energy, but to calculate sound energy is not so easy. So I would put it as potential energy. Ah, my pen is now starting again. I don't know, does it do that when it's weak or like, but it's fully charged. I would put it as potential energy, because the reason for that is when that kinetic energy comes to a stop over here, let's say that was kinetic energy over there, and this is now potential energy over here. Does it make sense? Okay, you convert from one form to the other without moving. So the energies that we're dealing with is this, because that brick still has potential. Let's say this was just the first floor. I mean, this was falling from the fourth floor. So now it sits on the third floor. What if you kick it again? Then it can still go down. Are we together? So to be safe, I would put potential energy there. Are you following? Sound energy might also be, but the scope that you are having in terms of calculating energies are mainly on potential and kinetic energy. Are you following? Now they want us now to calculate the initial gravitational potential energy of the block just before it falls. Now we need to show that. Okay, initial gravitational potential energy. So what do they want us to do? They want us to calculate potential energy. So we can say potential energy is equal to right. I don't know what is going on with this. Will be mass multiplied by gravity
Gravity.
multiplied by height.
Height.
So in short, we can say energy potential, sometimes they put it like that, will be mgh.
H.
All together.
Yes,
Right. So we've got the mass of the brick, we've got the gravity, we've got the height. So if you plug it in, the mass of the brick was 2.5, multiply that by 10, which is the 10 newtons per kilogram, because I've got this in kilogram, and then you multiply that with the height. What's the height? The height was 3 meters, isn't it? So the kilogram will cancel, and then you would have this now in Newton meters, which is the same as joules. So if you do that correctly, it gives you 75. Are you following, guys?
Yes,
yes,
sir.
sir.
Okay. I don't know, Chance, you are having feedback there. Okay. So guys, we move over to the next one. This question is actually a little bit more detailed than the previous one. Huh? So my pen is just giving me issues again, but let's go. Write down the kinetic energy of the block just before it hits the ground. This is where energy conservation plays a role. So the kinetic energy just before it hits the ground. Are we together? So now that kinetic energy will be the same as the potential energy. Are we together? Due to what? Energy conservation. So one could say that the kinetic energy that you had is the same as your potential energy. Are you following? Now we've calculated that the kinetic, and the potential energy in the previous one was 75. So I can say 75 equal to the half mass times it by velocity squared. Are we following? And I can get the kinetic energy. That's now a long calculation. But since they are already equal in this question, I can just, since it's just 1 mark, I can just say that this will also be 75 joules, or you could put it as 75 Newton meters. Either way is fine. Does it make sense, guys?
Yes, sir.
Okay. Now, the next one is going to talk about that. They say calculate the velocity of the block just before it hits the ground. Now, if this was the energy just before it hits the ground, then we can say that that kinetic energy, which includes now the calculation for the velocity. Okay. Guys, this is what is this? Mute yourself there, please. Okay, so this is what happens there. Ooh, my pen is messing up, guys. So I want you just write it on a piece of paper. Just write it on a piece of paper. That you want velocity. Are we together? So one could say the kinetic energy, which we calculated or deduced in the previous one, was 75. That would be equal to half times the mass times the velocity squared. So we want you to make velocity squared the subject of the formula. Actually the velocity, because that's what you need to calculate. Are you together? Guys, are we together?
Yes, sir.
Quickly do that.
Yes, sir.
I give you 2 minutes. If you got your answer, just put it in the chat box there, please. I also want to see the formula that will say, for example, that's going to put it as velocity will be equal to, because that is made the subject of the formula. I also want to just write it down. I don't think you need to put it in the chat box because it has a square root in it, because the only way you can get rid of the square here is to root it. Yeah.
Yes. So
Okay. So kinetic energy, then potential energy when it stops. Yes, that's correct, Kenneth. Right, 2 minutes, guys. Let's see who can get it first in the chat box.
What's the
I want you to get me the velocity. What is the value for the velocity?
yeah, so but what's the mass of the block?
2.5. We're still talking about the same brick. 2.5. If you go up here, it's still the same brick here. 2.5. You see, this pen is working with maybe there's a bit of static electricity that is interfering. Maybe it's the sweaty hands or the clothes or something, so it's not communicating properly with its device. Okay, I got an answer. Yep, that's correct. Isaac, that's correct. Mariam, that's correct. Yes, Rosta, that's correct. Good. What are the units? Meters per second, huh? Perfect. So we are there. So your making the subject should look something like this: 2 times your kinetic energy over your mass. So putting the kinetic energy there would be 2 times your 75 over the mass of 2.5, and that should give you 0. Sorry, what's the 0? 7.75. If you round it off to 2 decimal places, yeah? All right, so that's fine. Okay, now you getting this, guys. Are you together?
So does it say round it off?
No, it doesn't. So you can leave it like that. Does it give you 3 decimal places? Exactly.
No, it gives a full calculated
Yeah,
display.
it's a full calculated display, so it's better to round it off at least to 3 significant figures. Okay, so that's what we have. Right, so any questions? I hope everybody understands this concept. Then we can move up. This guy is constructing next door. Is it not disturbing you? Are you fine?
It's fine.
Fine. All right, so after the block hits the ground, the contact area of the block is 0.008 meters squared. Calculate the pressure exerted on the block, by the block on the ground. State the equation that you could use to show this working. Maria put pressure there. Now we're going to calculate pressure. So the concept is this block is now falling down. So we've got this block falling down all the way from the top, and then the block comes and then it hits the ground. So it's a 3-dimensional block like this. Okay, so we can draw something like this. Now, after it hits the ground, the contact area of the block to the ground is 0.0. 0.008 meters meters squared, not per second. Okay, now they want us to calculate the pressure. Now, pressure by definition, this pen thing is messing with me. Okay, guys, let me try this. I'm gonna try to open it with another program and see if it still has this acting up issue. Let's give me a second. This program is not very friendly when you want to scroll, but I don't remember this program giving us any of these issues, né? Okay, so we're done with that. We're done. And then we looked at Paula and her friend Tuli. We looked at this, and then we are calculating this over here. Are we together, guys?
yes, sir.
Okay. I don't think, since maybe this is integrated into the iPad, it might not give us issues. Okay. Oh, I'm in the wrong question. I need to see how I can scroll between the pages without. Oh, why am I? What happened here, guys? Where's my question? Oh, I skipped that question. Sorry, guys, because I wanted to look at something that is similar to that concept. Okay, since we're doing now with pressure, let's look at the following. So we said pressure, yes, man, it must write like this, is equal to, say, the area over force. So how will you define pressure, guys?
So isn't it force over area?
Thank you very much. Thank you very much. Thank you very much. Thank you very much. I can see people are awake now. So stay awoke, guys. Thank you. All right. So it must be force over area. And that force has to be exerted on the area perpendicular. Yeah? So if you have to define this in words, what will you say? Pressure is the amount of force per area. That's the definition of it. Are you following? Okay. Amount of force per area. Okay, so the force that we have here, we calculated already then. The force that, no, we didn't calculate it, but we can calculate it because we've got 2.5 kg. That is mass, okay? So the mass can be converted to some type of force which we refer to weight. So if we do this, we have to do what? We have to divide this by 10. Are we together? 10 newtons per kg. So that will be how much? 0.25 newtons, isn't it? Are you following, guys? So that's the amount of force. So you'll say that 0.25 newtons divided by your area of 0.008 newtons squared. Yes. Am I doing something wrong?
No, Gina is saying you must let her in.
Okay, I'm let her in now. Okay. No, guys. I'm actually going from weight back to this. We actually have to multiply by 10 to get this. So your newtons will be 25, not 0.9. You remember, if you are changing, say, from mass to weight, what do? And coming back to this, you have to multiply by 10 newtons per kg. This side you divide by 10 newtons per kg. So we have to multiply. So it will be 25 over 0.008 newtons squared, meter squared. And then that will give you the pascals, because 1 Newton per meter squared is the same as 1 Pascal. Does it make sense? So please press this on your calculator. Give us what it gives you.
3,125.
125. Okay, that's the amount of pressure that will be exerted by the block on the ground. I can also ask you, what is the amount of pressure that you are exerting on the ground? How will you calculate the amount of pressure you are exerting on the ground? Let's say I weigh, last time I checked, I was about this amount. Okay, so that's my mass. If I change this to newtons, it will become 890 newtons. Are you agreeing? Because I multiply by 10 newtons per kg. Now that has to be exerted on the ground by my feet. So the area that I have here. So if I wear a size 8, then maybe the area around that, we have to calculate the area. And then after we get the area, then what will we do now? We take that force, divide by the area that you get, and that's the amount of pressure that you are exerting on the, what is this? On the ground or on earth. Does it make sense, guys?
Yes, sir, it does.
Okay, so now we are done with pressure. So that question is done. So we just want to go back to something we skipped. This one we finished. And then this question is on speed time graph. All I want to highlight here, guys, is that look at the shape of this. It's not a straight line, it's like a curve. Okay, and then here we've got a straight line. And then here we've got another straight line. So between M and Q, there is a non-uniform acceleration. Are we together? It is going up initially, but it's not uniform, because uniform has to be a straight line. Does it make sense? So between M and N, you would now say, okay, yay, someone is joining us for the physics class here. Yes, Papa is quickly busy with class, man. Oh, nice windbreaker, man. Give me a fist pump. Okay, sharp. See you later, man. Give me some water here. Take here. Come give Papa some water, please. Ask Andy to put some water to pop up. Thank you. All right, guys, sorry. Working from home now. So anyway, so if we go back to this, this will now be, if you have to define this, what will you say will this be? Non-uniform acceleration. Are you following? Guys, are we together?
Yes, sir.
Yes, sir.
Okay, so you will say that will now be non-uniform acceleration. Okay. All right, so, or you would say the acceleration is not constant, whichever way you want to put it now, it's in your own words. Are we together? All right, and then between P and Q, that's uniform, but it's going down, so that will be a deceleration. Uniform deceleration. So you can now say this uniform, or you could use constant deceleration. You can put it like that. Now calculate the acceleration of the bike in the last 15 seconds. Look here, it says the acceleration. So let's look at the last 15 seconds. Sometimes it's advisable to start counting from the back because you want to look at the last 15 seconds, right? So between this 5, is that 5 or what? The 5 should be from here, no? So this should be 5, okay? And then another 5, and then another 5. So the last 15 must be from Q to P. Are we together? But they said acceleration, but we know for sure that this is deceleration since it's going down. What did we say about acceleration and deceleration? Deceleration is a negative acceleration. Are you following? So you do the same calculation, okay? So then in this answer, now Rosta, this is not very straightforward. So here you could put your answer as negative. Actually, it is going to give you a negative if you're going to take the y change over the x change. Are we together? Since they did not write any word here as to acceleration or deceleration, you can just write it your way. Does it make sense? Okay.
Yes, sir.
So in that case, what will we have now? We will now say the change in my y against the change in my x. So the change in my y is what? The change in my y is from here to there. So the change in my y, which is my speed, will be 40 because it's from 0 up to 40. You can read that. Now the change here in time is 15 seconds. They already gave us this. From 30, 35, 40, 45. Are we together? So you will now have 40 divided by 15 will give you your acceleration. But because it's negative, are we together? You'll get a negative answer. Where you'll get a negative answer is because you see your change. You're starting from 40 going down, and then from 30 to this side. Are we following? So if you had to put it in maths, you would say your coordinates here would be 30 and 40. The coordinates here would be what? Would be 45 and 0. Are you following? So if you now come and you make your x1 and y1 and you make your x2 and y2. So if we take the x2 and the y1 x2 and the y1 2, you will say the change in your y over the change in your x will now be y2 minus your y1 and your x2 minus your x1. So your y2 is 0. So 0 minus your y1, which is 40. And your x2 is 45 minus your 30. So it will be negative 40 over 15. Therefore, your answer will be negative. Does it make sense, guys? If you apply the mathematics behind it. Okay?
Yes, sir.
Okay. But because you know the shape, just from the shape, if you look at this shape that you are having over here tells you that the gradient here will be negative. Are we together? And this should be now a graph that shows in this side to this side. Okay, so the speed there, you were going fast, now you're coming to a standstill because the speed here will be 0. Here the speed is continually increasing. Are you following? So your final answer will be negative 40 over 15. I don't know how much that is giving you. Maybe 2 something. I don't know. So the answer there will be minus 2 point something there.
7.
2.7 if you round it off. Give me to 2 decimal places, so it was 6 and something. 2.6 what?
2.67.
7. Please, if they are not specific, try to keep it to 3 significant figures rather than just 2 significant figures or 1 decimal place. Now, please do that. Okay. Now calculate the distance that is covered between N and Q. Now this question is very specific. Where is the distance between N and Q? So now you need to go to the graph. Let's just clear some space. The pen is working so smoothly. So that program is not very compatible for what we're trying to do now. So they want you to calculate the distance where between P and Q. Are we together? So you want to start from P going to Q. For you to get the distance, it must be the area under the graph. Therefore, you need to close this and close this and close this before you can find the area of that. Does it make sense? Now, what kind of shape is this? This is a rectangle, isn't it? So you will now say the rectangle will now be your length multiplied by your breadth, or length multiplied by the width, whichever you are using will give you the same answer. The length is 15. To there, that would be 15. If you take the difference between 30 and 15, and from here to here would be 40, from 0 to there. So it's like saying 15 multiplied by 40. So if you do that, 600, yeah? Yeah. So you show here that 15 multiplied by 40 will give you your 600. This is probably a 2-mark question. We want to see that, and we want to see that. Okay. Any questions? Are we fine? Guys, are we awake? Show me thumbs up if we're awake. Only chance. Okay, 9 people, 14 people, 18, 20 people, 25 people, 26 people, 27 people, 28 out of 40, 30 out of 40. Let's see if we get a 41 out of 41. Okay, 30 out of 40. What happened to my 11? The other 11 are sleeping on. Anyhow, so we can continue with this. So we are done with that question. We did this question. We did this. This is again something on energy conservation of energy, changing from one form to the other. This is a topic that we don't really thoroughly teach. We just say self-study and so on. So we can just run through it again. It's almost the same thing as your brick that was falling down, or the palm fruit that was falling down. More or less the same thing. So I'm not going to spend a lot of time on it. Here they are showing us that Jonah has a mass of 25 kilograms. So she is weighing 25, or is it a he? I don't know, he or she. And then it's moving from point A all the way up to point. So you're moving up from point A to point B. Does it make sense? Okay. So now they're saying using the movement was up using a skateboard, ignoring the effect of friction. So you don't, the skateboard is on the ground, right? So you are taking as if there's no friction. Now calculate the kinetic energy at point A. Are we following? Right? So how do we calculate kinetic energy? We'll say energy, which is kinetic, will be how times the mass times the velocity squared. Now they are saying she's moving, so there's already movement. Point A doesn't say that she's stationary. So if we do that, we'll say how multiplied by a mass of 25 kg multiplied by the velocity. They also told us at what velocity she was moving, isn't it?
Yes.
Which was 8, isn't it? So you square that 8. All right. So we can have it as 8 meters squared, 8 meters per second. So if you do this correctly, they already even give you the joules here. It will give me 800.
800.
Okay. Yeah, my calculator says 800 also. Yep, I got a calculator now. Right. So now, after that, we move up. So then she stops at point B. So remember, this kinetic energy that was moving, when it comes to point B over here from A, you'll have the same energy over here, isn't it? Because of the law of energy conservation. So therefore, the potential energy, just says she has got the potential to slide down again, will be the same. So it will be 800, 800. This is always a follow-up mark. Did you see with the brick as well, ne? So we get the trend. That's the purpose of this, ne? We're going because of this, ne? We're training question papers. And then calculate the height, h, and give the unit, okay? So if we have the potential energy to be the mass multiplied by gravity multiplied by height, we've got the mass of 25 kg. We've got gravity of 10 newtons for every kg, and we have the height unknown. Potential energy we have as 800 joules. It's the same thing. Now we can calculate it. Are we together? All right. So if we do this, remember I also told you that this can be written as 800 kilogram multiplied by meter squared second squared. This will start making sense if you start canceling it out. You can take this as 10 meters per second squared. So the second squared, one of this would cancel with that. And then from the kilograms will cancel, and you'll only have 1 meter. So we don't use the units like joules and so for calculations. If you want to see how the units are disappearing. I hope you understood what I'm trying to show you here.
Yes.
Yes.
Okay. Okay. So if you understood, that's perfect because I was a little bit fast on it. So for the height, you just have to take that potential energy formula and make H the subject of the formula. Né? So the potential energy is mgh. So what I'll do is to divide by mgh on both sides. So the mg will cancel on this side, not on that side. Then we just have the h. So we can say h will now be equal to the potential energy divided by the mass multiplied by the gravity. So the potential energy was 800 joules divided by the mass. Well, I said actually kilograms times it by meter squared times it by second squared. The mass of the girl was, or the boy was 25 kg. The gravity we said is 10 newtons per second. Okay, 10 newtons per meter second squared. Okay, so the kilogram will cancel. The 1 meter with 1 would cancel. The second square cancels. I only have meters. So my unit for the meters, see my calculator, giving me 3.2. So the height will be 3.2. Guys, there is no way you can fail this kinetic energy and potential energy question, guys. Because we've really looked at the brick, we've looked at the palm fruit, we have looked at this skateboard situation, and all of them had all the elements that you could possibly be asked under that. Okay, can we move on? So we are done with that one. Then the next question. Guys, do you notice that from those papers from 2010 up to 2020, we are doing the first ones from 2010 upwards now. Né? The reason for that is because we have looked at the papers from 2015, 16, 17, 18, and 19, 20. So we haven't really looked at questions from other papers. That's why I opt to start with those ones, so that when we go towards the end, most of those questions would start look like it will be more familiar for you. Those of you that have been with us for some time now. Okay, so let's look at this question. Here, we show a car that travels from Chumep to, pick up my stationery. So the car is traveling from Chumep to where? Ondangwa, guys. I said unmute yourself, so we are having an interactive lesson. Right, so the car shows from Chumep to Ondangwa. The average speed of the car there is 100 kilometers per hour. The distance that is covered is this. So this is now the speed. This is the distance. I know Ms. Bugula likes to do this in your math papers, especially if you have those questions that you have to take from a sentence or a paragraph into algebraic equation. So you write it there. Right. Now state what is meant by speed. Now speed is the distance covered by time. So you can say speed is distance, the rate of time, or the rate for the change in distance. Are we together? Remember we said that, isn't it? The definition of that. Remember in the very first question that I did. So you can even put it like this. You can say speed is distance per, don't say time, eh? Distance per unit time. Please add this term unit to it. The distance per unit time. Are we together? So you could say, if you define it from the formula, speed is the distance per unit time. Guys, next week, I do not want to go through general physics again. Even from your questions that you put there are mainly from electricity and so on, waves and so. So please make sure that you understand what we're doing here. You can go through the video again on your own so that we can move further. Is that making sense?
Yes, sir.
Okay, that's why I'm really slow on this. Né? Remember, physics is only next week, Thursday and Friday. So we're really moving because I don't want to do general physics again. Okay, so we've got this. Another way of saying that was the other way we put on in the other question, we say it's the rate of change of what? Of distance. So either way, you put it like this, you could put it like this. All together. At what rate is the distance changing with respect to time? So if you have the speed, that could be maybe the first derivative. I'm very excited to teach AS level maths next year, especially with this group, because this will be the biggest group if you continue with us. How many of you would like to do maths on AS level? Just raise your hands.
Oh no.
If you want to go into civil engineering, it's almost a must. Yes, almost a must. Architecture, almost a must. All right, so I've got about 12, okay, 12, 13 people. Interesting. Okay, I need a group of at least 10 to 15 to make it happen. And I can guarantee you an A in physics and chemistry next year, because we're going to start as early as the 1st of Feb. While your papers are still being marked the whole of Feb, you get your results somewhere in March on an unknown date. Already, you might have covered 3-4 topics before you even started school, so that we are ahead of it. Yeah? Those of you that know, I'm sure this physics you can write C or above. So if you are interested, we will also let you know. Mauritius, if you're continuing, get me your 10 clients and then I will give you free lessons there for the rest of the year. If your
Yes,
clients
sir.
are dropping out, then I will also look accordingly, pro rata. But anyhow, that's the answer we've got over there. Then we go further. Calculate the time it takes for the car to reach Ondangwa. Okay, I've been there. Nice place, very far, but yeah. All right, so we know that from our triangle, what do we have here? We said speed is distance divided by time. What are they looking for? They want us to calculate the time. So the time, if you close time, you would have only distance and your speed. So time will now be distance and speed. Charlotte, can you see the green? Is it okay? Charlotte has a problem with the colors. Okay, so we will now put the distance. What was the distance that was covered? Did they tell us? 250.
150.
And the speed was 100 kilometers per hour. I'm writing 250 kgs. Does it mean I'm tired? Kilometer cancels, you'll have it only in hours. So that will be what, 2.5 hours, isn't it? I would together,
Yes.
2.5 hours.
Yes, sir.
Some of you could even write 2.5 hours, nah? Like that. That will also be accepted, but no, will not be accepted. You know why? Why will this not be accepted?
They put the unit for us already.
Exactly. They already have the unit for us. So that if there was no unit, this would have been accepted. Or even your the 90 minutes would also be accepted, because your 60 plus your 30 will give you 90 minutes. Just different units to display. Okay, I'm just showing you other options also. Now they want us to calculate what? The weight of the car is given as this. Calculate the mass. This is very easy. You're changing from weight to mass. Going back would now to divide by 10 newtons per kg, so the Newton cancels. If you divide by 10, the weight of the car will be 2,400 kilograms. So it's the same as you see. The formula says weight is equal to what? Kenneth, don't do that, please. All right. So the weight is equal to your mass multiplied by your gravity. Are you following? Are we together? So now you want now only if you put it now in your what is this called? Your triangle, you'd say weight will now be the mass times the gravity. Remember, gravity is a constant, newtons per kg. So if you only want the mass, it will be this divided by that. So that 24,000 divide that now by 10. Are we together? So the weight Newton and Newton kg. So this and this will cancel. That's how we got that. So I'm just elaborating a little bit. Of course, we know it now. Okay. The next one, they are saying you've got force A and force B becoming equal. So if you look at the car, here, let's zoom it in. Here they are saying that force A that is moving forward, all right, is equal to force B that is moving backwards. So which means they are equal to one another. If they're equal to one another, that means it's neither going forward or it's neither going backwards. So what does it mean? The car is stationary, isn't it? So we understand the language there. Are we together? So first they want us actually to put the types of forces there. Okay, so the force name here would now be the driving force. The driving force. Sometimes they even say the thrust or whatsoever, but driving is quite neutral. Now B, remember, this is the force acting forward. That's not A. Now the force that is acting backwards, we will put in a different color. What do you think that could be? What kind of force could it be? Common name for force that the opposing force is friction, man. Okay, so you could say there is resistance due to the air. That is fine. Someone gave that answer. Even if you say friction, that is also okay. Because on the car, it only shows the overall force. It doesn't specifically show you where that force is acting. Are we together? So we know due to friction, we also have a force down here that is acting in that direction. So if you put, and due to the air resistance here that's pushing like this against the car, we also have the force. Both of them are acting in the same direction. So basically, if they were very specific, the net force in that direction would be the air resistance plus the friction to get to the net force, which means the total. Okay, so that part is clear. It's a nice question, right? Describe the motion of the car when the force, when force A and B are equal. That's what I was talking about. So what's the motion of the car? Now, guys, we need to be very careful here. Né? Some of us, by first glance, could say the car is standing still, like a tug of war type of thing, if you're pulling with the same force in both directions. What if the movement of the car is exactly the same as the air resistance or the friction? Then you'll move at a constant speed. Are we together?
Yes, sir.
All right, so the most, this is now a question paper helping to say the car will be at a constant speed. Are we together? In other words, we're boiling down to inertia. If the object is moving, it will continuously move unless there's an external force acting on it. Are we together? Or if it's stationary, it will stay like that unless. So the correct thing to say there is to say constant speed. Or you could say there will be no acceleration, because acceleration is a change in speed. Guys, Chance, you are having put headsets on, Chance, please. Okay. So who's drawing on my board? Please stop drawing on my board. Okay. The one that Kenneth drew. Okay. Let's clear that. All right. So we've got that. So that part is okay. Let's see. How much do we still have? Okay, Maria, just put here forces. This is some hydraulics. Just want to see, it's quite some bit that we still have to cover. Guys, can I suggest this? All right, let me have a group discussion. The intention from here is to go to Delta so that we can continue with the class over there. And then I can give you the handouts. That's not a problem. Some of you have to come with own transport, or we can arrange the transport that you pay $20 to go back. If I give you the questions, if I copy the questions for you and you collect them, either here at Windhoek Technical High School or Polonium, and then we continue whilst you have the paper in front of you with this and the thermal physics online, or we go to Delta as usual. Those that connect online, those that come will come, which is fine.
Delta.
The ones
Delta.
that over Delta, okay, fine. Then that is anonymous, né? So we go to Delta, no problem. I'm just looking at the time. So the time is, we only have 9 minutes as per what we agreed on until 12:30. So I can quickly go through this as our last question, because I'm seeing that I still have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. About 16 pages. Because this is all on, I mean, not organic chemistry, but most of it on your general physics. So maybe we'll just still continue with the general physics, and then we'll go over to the thermal physics. Né? The aim is to finish general physics today. Okay, so if it doesn't finish from that side, we might even continue later, maybe until 8 o'clock or so. Né? But let's try to finish it. Okay, because I know your brain can only concentrate to a certain time, so I don't want you to get too tired. Né? Okay, can we finish this question? Then we stop here. Then we continue at delta after this.
Yes, sir.
Yes, sir.
Just give me an indication, those that are on the group that would like to come to delta, just raise your hands so that I can see how many copies I can make for this and the thermal physics. So 5, 6, 7, 8, okay, 9, 10, 12, okay, 16, 17, 18, right, 20. So 25 would be a safe amount, the number. But anyway, after this, also just give me a thumbs up on the group as well. I'll tell on the group as well. Maybe there are some people that are not in class now, but intend to come later. Okay, so here we've got the application of pressure. So we've got an hydraulic jack. Now the hydraulic jack, the concept behind it is you apply a small amount of force so that you can get a bigger output of force. Like the way the jack works in a car, you know, when you're jacking a car up, né? So you can pick up that car, like the previous example, the car was what, 2,400 kilograms. You can do it with just one hand with the help of the jack. So that's the concept. Now you see the power of science, né? All right. Actually, I want it to be very, very, you know, applying it in real life. One thing I'm praying for is to become part of the green hydrogen project. And then I want some of you to follow me on that when you go after your AS levels, when you want to do that. Who would like to come with me to the green hydrogen project? With me or without me, doesn't matter. As long as you can have a possible contribution to, it could be biology, it could be physics, chemistry, mathematics, even economics and accounting, or computer science, everything will be involved there. Né? So we need to raise a young generation that is hungry for these type of things. Né? Let's entice you. Okay, no, good number, nice. Then I will go and research on it so that we have direct access to it. Né? Organize some motivational talks from the guys that are working with. Some of them are my friends, and some I have studied with, and some I'll get to know as we're going. It's an interesting thing. But anyhow, hydraulic jack. Yeah. So this is a yemo.
As I'm from the begin class 2 of 2:30.
I think it's 2:30. Let's make it 2:30. Until 6. Okay. Or let's say 5:45, because I still have to get to church. All right. So in this case, we've got this force that's acting in that direction, and it has a total size of 160 newtons. So we've got the piston. If I draw a 3-dimensional piston, this is what it looks like. You know, those of you that are into cars knows that the car piston looks something like this, man. The top part, and then it has this type of thing, and then it might even have another one, and it pumps the oil, the compression in the car. So this is pushing down in an incompressible liquid. Né? Normally that is oil. So the same amount of force that you're pushing down on the small one is the same amount of force that is transferred without being lost, né? Because of the incompressibility. The particles are so close together that it's like just transferring that same force. However, when it comes here, it comes on a much bigger surface, and then it pushes out a much bigger force. But it's the small force that was multiplied. So it's like you are magnifying the force. That's the concept behind it. All right. So now in the question, they are asking us that the force 1 is applied on piston A, which is shown here. And then after that, we go further. Then they are saying that the pressure in the oil, the incompressible one, and the area of this piston A is 2.5 centimeter squared. When you start seeing centimeter squared and stuff like that, I advise you to just already see that this has to be converted to the units that we know. Are we together? Right. But in some cases, in some questions, they want you to come up with a unit. Now, in this case, remember in the other question, we said we could express it as 2 hours, 30 minutes, or we could express this as 90 minutes, or we could express it as just 2.5 hours. So if you are given this type of question, any of this will be correct. Does it make sense, guys? But if they already gave you the units here to say the pressure that I want must be Newton meter squared or in Pascal, then you should change the centimeter squared to Newton meters. Meter squared. Are you following? You get what I'm trying to say with the question, now? Okay, so the unit is, it doesn't matter. So I'll just keep it the way it is. So they want me to calculate pressure. I'll say force over area. My force that I have there was 160 Newton from piston A. If you look at it over here, and then the area was given as 2.5 centimeters squared. Therefore, my units will be Newton per centimeter squared. Just by putting that as the correct unit, you get a mark. Does it make sense? You get a mark for that working, and the third mark will come from the correct answer. So let's see. I get 64. Does it make sense?
Yes, sir.
That is when we use this. If we use meter squared, then the answer will be different. Yeah? Maybe we could just demonstrate it here. That means that this has to be changed. Centimeter squared has to be changed to meter squared. So in order for you to do that, you have now to divide by 100 and you divide by another 100. And that value you now have to take, and then you say 160 divided by that value will give you a very big number there. 100 are 2 zeros, so it may probably give you this, the 2 zeros over there, and then another 0. So if you use that, it will be 640,000 Newton meter squared. If you're putting it in Newton meter squared, which is also the same as 600,000 Pascal, which is also the same as 640 kilo Pascal or 640 kilo Newton per meter squared. This is not very common. So I'll just keep it as kilopascal or as Pascal. You see, the freedom you have to put it as a unit gives you all different answers. All of them will be accepted as long as your unit corresponds to that. Mauritius, your hand is up. Mauritius, you have a question?
No, sir, I forgot my hand.
Okay, no problem. So it depends on the unit that you are using. Any one of those could be correct. Okay. Guys, since we're only doing physics today, once you get these papers today, please just go and work through it again without looking at the video or the answers on your own, and then you go and look at the solutions. Né? Right. Since we're not done with it, I'll share the solutions after our class, the face-to-face lesson. Okay. So the pressure is then transmitted to piston B. So it comes from piston A up to piston B. Explain why the force 2 are larger than the force here. So you can say piston B has larger area. Okay? Because you could say because your piston B has a larger area, okay, then piston A. Okay, that could be 1 mark for that, or you can say A or vice versa, né? So you can say vice versa. Chance, you are having me on a speaker there, and that's why you are echoing. If you have headsets over there that you could use, because it's like I'm hearing myself, or I don't know what's causing that interference. Okay. So you could also say piston A has a smaller area than piston B. You need to talk as a comparison between the two. Chance.
So, so can you also say that piston B has a greater force than piston A?
They already tell you that it's a larger force. Why do you want to say what they said? This answer should come here. They already say, explain why it is larger. The force is already, they already state that for you. You understand? So if you say that you're just stating what they said, they wanted you to explain why that is the case. And the explanation is because the surface area is bigger. Does it make sense?
Yes, sir.
Okay, good. Now, the oil in the hydraulic jack has a density of that and has a mass of this. Explain what is meant by density. Again, mass per unit volume. That's the correct way to actually put it. Mass per unit volume. That is what density is, okay? Sometimes we accept the formula, but when it says explain, you could also say density is equal to mass over volume. Only when they say explain. But when they say define, you have to put it in words, okay? That's also another difference, another pointer for you. Nah? So if you don't know the sign of density to be like that, which we name rho, rather write it out there. Say density is equal to mass over volume. Okay, that's another way of putting it. All right. So calculate the volume of the oil. So how will you calculate the volume of the oil? You take this here, and then you
Mass
say the
over
density will be the mass of
density.
the volume. So what will the volume be? Mass over density. The mass is given to you, isn't it? 400, I mean 4,000 grams. I'm going to leave it in grams, no? Because this is also in grams. And then it will divide by 800 grams per centimeter. So this will cancel out. 2 of this will go, 2 of this. Your answer will be what? Hmm?
5 is the answer.
Is it 5?
Centimeters.
5 centimeter cube.
Cube.
Perfect. So that's your final answer. Okay. Any questions?
Okay, guys.
No,
sir.
no questions.
No, sir.
Okay. So we come to the end of the lesson. We can stop here. I just want to browse through, but I sent you the questions anyway, so you can anyway go and see. So the rest of them here, we've done this, so we don't really have to go through this question. We've done a bit of moments, maybe from a different angle. We can look at it. Speed velocity is there. Work done. Area, a bit of moments are there. Speed velocity, some pressure, weight, acceleration. Yeah, guys, this is, and then you've got the grade 11 paper that has a bit of momentum. So I think when we meet later, you see the same question we had here was in the 2020 grade 11 paper, no? You see that? Same question, the same concept we explained. So when we meet later, I want you to work through this paper, the one that starts with this question here. I don't know what page it is. This is your 2020 grade 11 paper. This is more or less. And I've seen with this one, I actually made sure that they do not ask you this, that chemistry question they asked you the last one, where you have to come up with explaining how you do the experiment. I made sure that we are not caught off guard. Hey, Rosta? Didn't make me feel nice. Okay. But anyhow, yeah.
EA Sports to the game.
Okay, guys. EA Sport, tune the game. That sounds very familiar. I started playing FIFA 06, ne?
Young.
So I'm quite experienced, guys. If you want some butt kicking to happen, you should come to my house so I show you, man.
Wow.
Okay. I like your confidence, man.
Che,
So you see, that's what they say. I like your confidence. Dream big, my boy. Dream big. Okay, guys, let's call it a day. I see you 2:30 at Delta. So
yes, sir.
have a blessed day. Bye.
Thank you. Likewise, sir. Bye.
Okay, I'll share the YouTube link on the group. All right. Bye.